Hey guys, so today we're looking at what the word extension means in terms of physics when we're talking about different springs. Now we we see this word extension in the equation force equals spring constant multiplied by extension. And we are looking at how much force it takes to extend a spring, so lengthen a spring when it has a certain characteristic. So your spring constant basically is how difficult it is to stretch the spring. So and a lot of people get this wrong. So it's a really important thing to be able to get your head around. It's quite simple once you know what you're talking about. So when we talk about springs, we talk about them being able to stretch. Now, to be able to say how much they stretch or how much they extend, we need to know a couple of things. First of all, we need to know what the term original length means. And we also need to know what the extended length or the extension is. Now, as you'd imagine, the original length is the length of the spring originally. So before you put any force on it. So right now, the length of this spring, if we're measuring it from exactly the same point each time, now this is difficult to do, but it's difficult to choose, but once you've chosen, you stick with the same one. I mean, I say it's difficult to choose. You just go, well, here and here. So it's not that difficult. You then measure the different distance between here and here. Now, for this example, it's 3 centimeters. Now the original length is the unloaded spring, so no force on spring. The original length is 0 force on the spring before it is pulled or stretched at all. Now, if we were going to do the extension, this is the amount that the string is stretched. So, amount string is stretched. This is actually calculated by measuring how long the spring gets to. So we'll get rid of that equation for now because we'll worry about that later. So imagine we've got our spring again. So the same spring, and this time we've put a force on it. And we've gone from here to here. So now our new length is this distance. That's the new length, and that's 5 centimeters. So the new length is now 5 centimeters. The original length is 3 centimeters. Now from this, we can work out the extension. So the original length was 3 centimeters, came to here. So the extension is the amount the spring has extended by, the amount it's increased by. So if we say original length equals 3, new length equals 5, we just take away the 3 from the 5, and we've got the extension equals 2 centimeters. So it's the amount the spring has stretched. It's the extra bit that this is gained by. So if we then went and increased the length of our spring even more, we could put an even greater force on it. Because this is the same spring still, but now we've increased the force on it, and the new length is now 8 centimeters. Now we're still going to work out the extension of the new one. We're going to do new length, take away the original length. So the new length is 8 centimeters, and we take away 3 centimeters because that's the original length. The original length is still what it started off with no force on it. So right here, we have 0 newtons. Here, it is increased, and here it is increased even more. Force has increased even more and made it stretch even more. So then we do 8, take away 3, and that gives us an extension of 5 centimeters. So the extension is how much the spring gets bigger from its original no extension length.